So let's start by having a look at some things called infographics. Okay, so infographics. They are ways of combining graphics, so visual tools, with some information and data as well, but in a way that is representative and useful. Okay, so you want something that at first glance gives you a very quick snapshot of what's going on. So, for example, what I've got here is a couple of images from Statistics New Zealand. They used in the 2013 census to display some of the information that they got from their census. So, for example, we've got under the Pacifica people here, what we've got is we've got a graph here of looking at the age distribution. And on one side, we've got the males, and on the other side, we've got the females. And one thing that we can see visually quite quickly is the fact that there is this shape that looks like a bit like a pyramid. And so that tells me that for younger ages, there is a lot of Pacifica people, and at the older age group, the numbers of Pacifica people are a lot smaller. So then on the right-hand side, we've got some information here about the change. And so it talks about how much it's increased, that the number of Pacifica people have increased from 11% between 2006 and 2013. It gives us our median age, and it identifies the proportion of the population that identify with at least one Pacifica ethnicity. As a comparison to that, here is the graph of the Asian population at the 2013 census results. And we can see at a glance here, there is a different shape to that of Pacifica people. So we notice now that for Asian people, that middle age group, 20s to 30, that's where there was a much greater number of people there. And in terms of children, there was a smaller number of children. And again, we've also got some statistics on the side about what proportion of the population identify as Asian ethnicity, how much that's changed, and what the median age of people is. So these are a couple of examples of some good infographics, way to visually display some information and give some really meaningful data in a hopefully easily digestible format for people to read, but in a way that is very accurate. So we don't want graphs that are misleading in any way. We want graphs that just tell us the data, tell us the results as it is. Now, what I've got for you underneath here, these are some examples of misleading graphs. Okay, and these are some of the things that we need to look for when we're given some kind of article, is how are the graphs represented? Are they done well? Are they not done well? So if I, for example, look at these ones here, I can see, looking at this first one, is that it's got a graph on the left is about Linux concerns, and the graph on the right is about Windows. So these are two different operating systems. Now, at first glance, I look at this one and say, oh, that first bar there, that's about the same size as that bar there. And the bottom ones, again, they're kind of getting smaller. So visually, at first glance, it looks like these two graphs are about the same size, but they're not. This is where I want you to have a look in a little bit more detail now. And I want you to think very carefully about what's going on the axes. So if I go down to the axis down here, well, that was not very well done, let me undo that. What I notice is that this axis here goes from 5 across to 40. So the maximum is up at 40. So then in terms of Linux, the biggest problems are about 40%, okay? Whereas when we're talking about Windows, you notice that this axis goes all the way up to 80%. So this value here is all the way up to 80 as compared to the one on the left-hand side, which only goes up to 40. So in actual fact, Windows are double the size that Linux is. Or Linux is half of the size as Windows, 40 compared to 80%. So that's quite a significant difference. And it just comes down to how the graphs have been displayed that makes it appear that it's actually okay, that it's similar, when in actual fact it's not. So that's one type of thing that we want to look for. We want to look at those axes when we're making comparison to make sure that it's a fair comparison that's being made. Another example is this one down here. In three-dimensional pie graphs, these are one of the things that I really don't like. And there's a good reason for that. As a statistician, when our brains look at graphs, we look for area. We look for how much is coloured in one colour, how much space is coloured in another colour. And our eyes automatically compare those. We are less likely to look at the actual numbers and see the comparison with the numbers. So I want you to have a look at these graphs here. And if I just look visually, it looks to me like the front one looks like it might be bigger. Because of the way it's located at the front, the amount of surface area for the Air Force looks to be a bigger size piece. However, that Air Force is only 26%, whereas the Army at 35%, that piece should be much larger than the Air Force, but it's hard to get that understanding. Equally, the Navy's at 27%, so this yellow piece there should be of similar size to that Air Force piece, but in actual fact they're not. So this is misleading us. And any kind of three-dimensional graphs are not good, in my opinion, because of the way our brain interprets three-dimensional objects. Here is another one that was sourced more recently in 2014 from the Herald, and they've got it from the AA website. When you look at this graph, it looks, oh yeah, pie chart, okay, refined fuel, fuel excise, GST, different components of cost, awesome, cool, it looks fine. I want you to have a little look more closely though. Look at the numbers. And in particular, I want you to look at the fuel excise. That is 30%. Now, when you look at this section here, and then you compare to the refined fuel section, which is 35%, which of those pieces looks bigger? To me, the fuel exercise looks like it's a bigger piece, but in actual fact, it's only 30%, whereas refined fuel should be bigger at 35%. Equally, I want you to look at the importer margin versus the GST. So that's talking about 13% compared to 18%. Now, if I look at the size of those slices, they do not look 18 to 13. It looks like it should be the other way around. So this is, again, a very misleading and badly constructed graph. And so that would be something that we would evaluate in our report and talk about how this is an issue with this particular graph. Now, equally, you might get some graphs that are perfectly fine, that are a really good representation. They're drawn well, fair comparisons. And in that case, that's a comment that you can make in the exam that, look, these graphs have been well drawn, the axes are similar, they are fair, it's a fair representation of the data itself, and therefore is being accurately portrayed, and I can have confidence in those graphs. So we need to look for both the good and the bad when we're looking for evaluating a graph.